Hey guys, we are back. We have Gaurav Shukla here, co-founder of QuiCash. He is a former EIR at Matter Labs, and he'll be talking about privacy.
All right. Thanks a lot for the intro, and let's jump right into the presentation. So I hope everyone is able to hear me. Welcome to the session. It's been great that you all were able to come here. It's been crazy few past weeks. What we want to talk today is more or less about how Taproot works. Just get a helicopter view. It's kind of really futile to try to explain how Taproot works in 10 to 15 minutes. So understand, we just gotta take a look at how Taproot works a little bit, and then try to figure out how linkability works for Taproot. All right, a little bit of my background. I was previously at Matter Labs as an EIR, and my most recent gig is building a privacy implementation for QuiCash. It's a paper by Sarah Michaeljohn from University College London, and it's been going great. So what exactly do I mean by privacy? Privacy, the way I see it, I keep them in two buckets. So you have confidentiality on one end, and you have anonymity on the other. Confidentiality, the way I like to explain it, is when the number of tokens that you're sending someone is encrypted. Something like all encryption or person commitment. These are some of the examples of the projects that implement confidential transactions. On the other hand, with anonymity, what you're trying to achieve is break the transaction graph. And to do that, the most common approach is you just throw an anonymity set at it. Mixers are a really good example of that, but mixers are only bounded by the number of keys they could have in a transaction. This is what sometimes is referred to as K out of N anonymity. And the goal always is to reach to N out of N anonymity, where N is the total number of coins in the system per se. Then there's also this argument that you can achieve anonymity using sidechains. Since nothing is on chain, then everything could be private on a sidechain. But then that comes with its own problems like on-ramp, off-ramp. So what are the crypto primitives that are available today? So we have tumblers, which are kind of famous for all the mixing services. We have zk-SNARK-like implementations. So we have Zcash, which is based on zero cash. And then there are these new implementations that are coming out of SNARKs. We have something like ring signatures. So you have Monero and 37 forks of Monero. And then we have badging and aggregation from Mimblewimble and Grin. And I think Tari is also working on it. So the motivation is that you are able to link the transactions back to the sender because you have the same keys recurring again and again in the system. And in Monero, you have something like intersection style attacks. In Grin, you have something like eclipse style attacks. And the whole idea being, how can you mitigate this? So from my understanding, what they're trying to do in Taproot, if they want all the transactions to look the same. And what I really mean by that. So you have pay to pub key hash, and you have pay to script hash. These are just way transactions are constructed in Bitcoin. And if you look at the blockchain, they all look different. And different is bad. We don't want different. And kind of like take a step back. How do we think about Taproot? So if you know how scripts work in Bitcoin, you have an opcode called opReturn. This is used to timestamp data on the blockchain. So say, for example, you want to file a patent and you want to timestamp it, that you came up with the idea first. So you create an opReturn transaction, and this makes your transaction unspendable. Like there are people trying to create chat apps, and they like to put some hash in the blockchain, and I think that's why they use opReturn. It's kind of really cool feature, but it kind of also bloats the blockchain. So if you look at something like blockchain.info, they consider all returns to be part of UTXO set. And that's not a good practice to have. So Andrew Poelstra came up with this idea of doing pay to contract hash. Now, this is actually an addition of a really confusing terminology in Bitcoin, because this has nothing to do with contracts, and this has nothing to do with scripts as well. What this basically means, you are taking some data, and instead of sending an op return, you are sending a signature with the commit of that data. Now, what does that mean? We are going to follow the syntax of a Schnorr signature. I think because Taproot is switching to Schnorr signatures, it's better to kind of get that syntax up right. So in a Schnorr signature, this is how a secret key looks like. And I promise this is the only equation I have in all the slides, so just bear with me. So a secret key is determined by having a random nonce, which is k in this situation. What if we could commit this data in this random nonce itself? So you kind of, instead of having a random nonce, you create a new nonce by adding the hash of the data that you want to push to the chain. In this case, the small j becomes your new random nonce. So just to kind of recap, now instead of sending data on the chain with an op return, you're sending data on chain with a signature. This kind of achieve a 0 byte op return, because now there's no real transaction that's going on the chain, which is unspendable. So if you kind of follow that, that's exactly what tab tweak is. The idea being that you can tweak a public key. So you can tweak the public key and the secret key to commit some data on it. And the properties this gives you, that you can sign the transaction without revealing what the data is. If you know the tweak, you can obviously spend it. And you can, at some later stage, say that, all right, I know the pre-image of this hash, and there's no way that I could have forged it. So if you understand things till here, you understand Taproot. There's the core idea that you take some data and you commit on it using a public key. And that's what Taproot does. But instead of the data, now you have scripts. All right. With Taproot, the core idea being that you can reduce fees for the transactions with multiple spending conditions. And what really happens when you have multiple things to store in a blockchain is that you just throw a Merkle tree at it. And that's the approach that Taproot takes as well. So what they use is something called Mercurized abstract syntax tree. I think since we are doing this very basic helicopter view of the protocol, it's not necessarily to know what's there on the leaves of these tree. But then the idea is very basic here. So you can either do a key pot spend, where you just spend it like a pay to pubkey hash. So you just do a signature and then you spend it. Or you can do a script path spend, where you have some script that you want to reveal, and then you do an inclusion proof that this script is in that Merkle tree. So there are other really cool possibilities with Taproot that we are not going to talk today, but I wanted to kind of touch on, is the idea of music. So you have n of n signatures, and you add all the pub keys together to create a new pub key. So that's kind of the tab tweak. And if you also add all the secret keys together and then you multiply it to a generator point, it becomes a new public key. You don't have to worry about all that. It's kind of more technical deep dive. If you want to kind of really understand it, I recommend you go and read BIP 340, which is for the Schnorr signatures. So this music that you achieve, which creates this new pub key, is not actually possible with ECDSA. And that's why Taproot is switching now to Schnorr signatures. There's this whole idea of doing adaptive signatures, which is also very interesting. where you can do a hash time lock contract without actually revealing that this transaction is a HTLC. This is kind of really cool. And I think I touched on this very early in the presentation, that what if every transaction looks the same? And this is what Taproot kind of achieves by committing on the whole Merkle tree of the scripts. That no matter what spending condition you put into the transaction, if the parties are cooperative, then you never reveal those spending conditions. So it just looks like a pay-to-pubkey hash transaction. And there's other really cool stuff that you can do with Taproot that we're not going to cover today because then it may become really technical. I want to keep it a bit easy. So we talked about committing on scripts, but we didn't really touch on this idea of policy privacy. So Peter Vola talks about that we do not achieve confidentiality, we do not achieve anonymity, but what we achieve is policy privacy. And what that means is policy is just a higher level language that translates to miniscripts. And miniscripts is also an easier version than scripts, because not everyone is able to code in scripts. Miniscripts compiles down to scripts. So just to have a little conclusion here, linkability is still not solved in Taproot. If you do want to delink your transaction, I think you would still need to use something like CoinJoin. And how many people would actually end up using Taproot is still an open question. For the technical deep dive, I recommend you look up BIP 340, BIP 341, and BIP 342. BIP 341 is the Taproot implementation BIP, and 342 kind of specifies the opcodes that they are changing to be compatible with BIP 341. It's already in the status track, so I hope this kind of comes up really, really soon. I wanted to keep some time to kind of answer questions, so I think at this point, I'm happy to talk about whatever you guys want to talk about. So I feel like there's not many questions in this talk. Okay.
Cool. So we're going to wait maybe another 5 minutes. And if we don't get any questions, we can just take a short break until our next session. Thoughts on Gren?
Yeah. Introducing Schnorr means hard fork. No, so like minimizing.
Can you read the, Gaurav, can you read out the question before you start answering it?
Yes, yes. When is Taproot going live? Taproot is still in the standard track. We don't necessarily know when it's going to go live. I think there's a lot of political debate around it. So let's see when it actually goes live. I don't have an answer for that. Like minimizing the amount of data for a block. That is correct. So the fees are charged by the amount you take up in the block. So it will minimize the amount of data that a transaction takes in a block. All right. We need to send me a paper for this, but it sounds like you're saying that we mask transactions using Taproot. We are not masking transactions. All we are doing is committing on the scripts that's used to create transactions in Taproot. So what do we lose or gain for this in simple words? So in Bitcoin, we have something called pay-to-pubkey hash, and we have pay-to-script hash. These two transactions look different when you look at it because they have different spending conditions. In simple words, these two transactions will start looking the same as soon as you implement Taproot. I think that's a very simple explanation. The privacy that you achieve with Taproot is the privacy of the spending scripts. How do you anticipate 342 to affect future use cases? That's actually a very good question. So there's a lot of use cases that I think that will be really, really important. So one would be where you are doing SDLC without anyone else knowing that you're doing an SDLC. Another condition could be where you create a transaction with some spending condition, which is not even true on Bitcoin. So say now you have some scripts, which is true for some sidechain, and now you create this transaction, and the spending conditions are such that the transaction is valid on some sidechain. So it creates this interoperability property with Taproot. And I think that's something that I'm personally really, really interested in. You can do threshold signatures. So I think as of today, you cannot do threshold signatures with Taproot. And this is something that's still in the works because there is malleability. But there will be someday when you will be able to do K of n multi-signatures. Right. Does replacing ECDSA with Schnorr imply a hard fork? Yes, that's correct. Okay, so I think that's all the questions we got. Is there something, if you guys want me to repeat, I would be happy to do that as well. If I wanted max privacy of transactions with existing tools, how would you do it if total new? That kind of rhymes. So I would kind of strongly suggest that if your life depends on it, don't use the privacy tools because they are still malleable to a lot of attacks. But then you also need to kind of think about what you mean by privacy. So do you just mean confidential transactions, or do you mean anonymity? If you are trying to achieve anonymity on Bitcoin, I think your best bet is using something like CoinJoin. But if you want confidential transactions, I don't think Bitcoin supports that yet. Yeah, so difference between ECDSA and Schnorr. So the cool part about Schnorr is that it gives you this linear properties that you don't get with ECDSA. And it's a much simpler implementation than an ECDSA implementation. And then you have all these really cool properties of doing a tap tweak, which you don't get with something like ECDSA. Love threshold sites, help with usability of an individual. Okay. All right. That's a good question. All right. Is there anything else you guys would like to ask? Yeah, so Wasabi Wallet is the implementation for CoinJoin, and it kind of works as a mixing service. So you would be able to use Wasabi Wallet to do mixing on Bitcoin. So that's the general approach there. Are you on CT? I don't know what you mean by CT.
All right, guys, I think that's pretty much it in terms of questions for this session. So we're just going to take a short break and transition to the next session in 10 minutes. Thanks so much, Gaurav. You were great.
All right. Thanks a lot, everyone.